Hello everyone and a very good evening. So before we start, first let me know if I'm perfectly visible and audible to you or not. Yes, you can write in the comment section so that we can start. So we have Suresh Tagore, Yuvan Aditya, Bhagyavardhan. We have Fenil, I am good, thanks for asking. We have Simran, Raj Nandini is here. Nikesh Madhvi. Yes. Abu Tahir says you're perfectly visible and audible. S. Yashwant is here. Bhumika. Sarat Nivas A. Udhaya. Bhavika. Diksha. Indrani Bhattacharya. Cool. So there is no glitch at all. So we can continue. My name is Khushbu and welcome to the new crash course for term 2 that we are launching today. So as you would have seen the title of the video, today we are going to have a discussion on arithmetic progression. So it's going to be a one short session. So whatever concepts you have in the book, all will be covered in this session today. Yes. All right. I can see a lots of thumbs up in the comment section. Yeah. Okay. So without wasting any more time here, let's start the session. So first of all, what arithmetic progression is? Before we look at the mathematical definition, let's first take a look at the visual representation. So look at the way the boxes are stacked in this picture over here, right? Look at them. From the side, you will see that each layer increases by a fixed amount. You would see that in the first layer, there is only one brick. Then if you take a look at the second layer, you would see that there is one more brick than the layer above. In every layer, one brick is increasing. Every time it is increasing by one, we can see, right? Yes. So this is the visual representation for arithmetic progression. Now let's take a look at its mathematical definition. So mathematical definition states that it is a sequence of numbers in which each term is obtained by adding a fixed term to the preceding term except the first term. Yes. So what does this mean actually? So here, the first term, it is actually denoted by A, right? And the fixed difference, the fixed amount that we are adding every time to the previous term, that is actually called the common difference, which we denote by small d. So every time to get the next term, we add the previous term to it, right? So basically, what we are doing here is first term remains as it is, and then for the next term, we will be adding the fixed amount, the fixed term to it, right? Now, let's try out a question to understand this. The auto rickshaw fare in a city is fixed at rupees 14 for the first kilometer and rupees 8 for each additional kilometer travelled. Does this situation represent an arithmetic progression? Yes. So to check this, whether this is an arithmetic progression or not, let's take a look at this. So here this is the auto rickshaw. For the first kilometer, it is fixed that rupees 15 will be charged, right? For the first kilometer. Now for every subsequent kilometer, it is charging rupees 8. So for this additional 8 kilometers, right, the overall fare then becomes 23. Now if it moves forward, if again it covers one more kilometer, we again add 8 rupees to it, right? It becomes 31. Again, if it moves forward, it covers one more kilometer, we add 8 to it, right? We get 39 and so on like this. So what do we see here? We could see that here the common difference every time was same, right? Every time we add 8 to it, we get the next term. So since the common difference is same between the two consecutive terms, we can say that yes, this is representing an arithmetic progression. Nikesh, its form in AP as succeeding term is, yes, I could not read the entire comment, but yes, that's how we get an AP. In the succeeding, for whatever term you get, you have to add the fixed amount to the previous one. Yes, Bhagyavardhan, AP 15, 23, 31, 39 and so on. Yes, Hitesh, you have a doubt? Yes. Yes, you can ask whatever doubt you have. Definition for arithmetic progression. In the definition you want to see. See, it actually shows us that it's basically a sequence of numbers, you see, right? Here, what are these? All these basically we just saw in the example. There are sequence of numbers in which each term, whatever term you get, is obtained by adding a fixed number to the preceding one, except the first term. In the first term, we do not do that, right? Yes. All right. So this is what the definition of arithmetic progression states. Now let's take a look at another question. So here we go for the AP root 8, root 18, root 32 and root 50. Write the first term which is A and the common difference which is D. Now that's very simple, right? Let's first write it in this way. Root 8 can be written as 2 root 2, right? Correct, Fennel. Yes. And root 18 can be written as 3 root 2. Root 32 can be written as 4 root 2. Root 50 can be written as 5 root 2. See, if you split it up this way, it will be easier for you to find out the common difference. Now that's very simple. Let's write in this way. 2 root 2, 3 root 2, 4 root 2, 5 root 2. Already this is an AP. We just have to write the first term and the common difference. So you see, to find the common difference, we subtract the first term from the second term, right? So 3 root 2 minus 2 root 2 will give you root 2, positive root 2. 4 root 2 minus 3 root 2, again positive root 2. 5 root 2 minus 4 root 2, again positive root 2. So from here we know that first term is 2 root 2 and the common difference is root 2 every time. Correct? Yes, Diksha, Pavan Kumar. Yes, Suresh Tagore. Thanks for crash course by Jews. Always help me. Thank you, Suresh. Charvi, first term root 8, common difference root 2. Yes, or you can write it this way also. That is also correct. I can see. Yes, that's correct. I can see all of you have given the right answer. Absolutely. Right. Now, there is an important thing about common difference. See, common difference can be positive, it can be negative, or it can be 0 too. For example, when you are going down the pyramid, you would see that the count of the brick is increasing every time, right? So the common difference in that case would be positive. Why? Because how do we find the common difference? We subtract the previous term from the next term, right? When next term is bigger in value, so definitely the difference would be positive in that case, right? Okay. But when we are going up, so what we see is that in that case, common difference is going to be negative, right? As I said, because when you are going up, the size over here is decreasing. Then I mean the number of bricks are decreasing. So when you find out the common difference, it's going to be negative in that case. Similarly, as I said, common difference can be 0 also. Let me give you a simple example. Think of morning walks. Let's suppose first day you cover half of a kilometer. Next day also you cover 0.5 kilometers and every day you walk for 0.5 kilometers only. So a series of 0.5 kilometers you would see, a sequence of 0.5, 0.5 every day. So when you subtract them, you would see that the difference is 0 in that case, right? So in such cases, common difference is going to be 0 because it is neither increasing nor decreasing, right? Now, let's try out a question on this. For the AP, 3 by 2, 1 by 2, minus 1 by 2, minus 3 by 2, find the next two terms. So now we will learn how to find out the terms of an AP. Yes. Nikesh Madhvi. No, we do not have Menti today. We do not have Menti because we have come up with this new series. You can see it's basically a crash course, right? So here we are covering this entire chapter, the concepts of this entire chapter in one session. That's okay, Virushka. Whatever you have missed, you can watch the recorded session on the YouTube later on. Okay, so let's first write them down this way, right? Now, to find out the next two terms, we would require the common difference. So, 1 by 2 minus 3 by 2 would give us minus 2 by 2. Minus 1 by 2 minus 1 by 2 minus 1. Similarly, here as well, the common difference is minus 1. We all know how to find out the common difference. So, common difference over here is minus 1. Now, to find out the next two terms, right? So, what do we do here? This is my last term here. So, what I'll do? So, to find out the next term, I'll add the common difference to it. So, minus 3 by 2 minus 1 will give me what? That will give me minus 5 by 2. Similarly, minus 5 by 2 minus 1, I'm adding a fixed amount, the common difference to it. We get minus 7 by 2. That's how we can find out the next two terms. That's okay, Subjot? Right. So, these are the next two terms. Alright. Now, let's take a look at the different types of AP based on the number of terms on the AP. Right? So, based on the number of terms, we can classify AP into two types. First is infinite AP, right? As the name suggests, here the number of terms will be infinite. That means it doesn't have the last term. So, let's take a look at few examples to understand this. Let's suppose we talk about natural numbers. So, it starts from 1 and extends up to infinity. So, you see there is no last term. So, we can call this an infinite AP. Why AP? Because the common difference over here is same, right? Alright. Now, let's take a look at one more example. Let's suppose we talk about odd numbers after 0. So, we have 1, 3, 5, 7. Again, we do not have a last terms. It is an infinite AP. It is AP because common difference is again same, right? Yes, Deepak, but there is first term. First term is here, that's 1, right? All right. So these are the two examples for infinite AP. Now let's take a look at finite AP. As the name suggests here, it will have a last term, right? Because it is finite. Yes, series of natural number, that's an infinite AP. Correct. Because last term is not defined there, right? If the last term had been defined, we would call it a finite AP. Yes, Anup Sahani, one of the easiest chapter, AP. Correct. Examples, natural numbers from 1 to 10. Just like I told you, when we have a fixed last term, then this becomes actually finite AP. So natural numbers from 1 to 10, you have first term, common difference is also same, but this time the difference is we have the last term. So that's a finite AP. D Deepak, we have common difference for infinite AP. See it. What is the name? What the name is? Infinite AP. It is an AP. So common difference will anyways be same, right? The only difference is whether it is infinite or finite. दोनों में common difference same ही रहेगा. Common difference change नहीं हो रहा है. Common difference तो वही है because तभी तो हम इसको AP बोल रहे हैं, right? Yes, Parth. I hope this doubt is cleared, right? Whether it is infinite, whether it is finite, but it is an AP. So common difference same ही रहेगा. All right. Yes, Ankit, when we know the last term, we call it AP. Arithmetic progressions, KTB vlogs, arithmetic progressions. Yes, Suresh Tagore, if something is finite, it has a limit. It has an ending. Yes. Understood. Great. Okay, let's see another example. So we have another example for finite AP. First 4 even numbers. Starts from 2. That's the first even number. 2, 4, 6, 8, right? So first 4 even numbers, last term is also there. You have first term. It is an AP. It is an arithmetic progression. So common difference is same every time. That's 2. Yes, Deepak? Great. Parjan, understood. Manjusha, understood. 3 by 2, 1 by 2, Ritika. See, as I told you, common difference can be negative, it can be 0, it can be positive. Because sometimes students have confusion over this. They feel that common difference can't be negative or it can't be 0. Like you said that question, 3 by 2 minus 1 by 2. How do we find out the common difference? We subtract the previous term from the next term, right? So from 1 by 2, we were subtracting 3 by 2. That's why it is negative. Ritika, I hope your doubt is clear now. Yes? Correct, Lakshmi K, 2 is the common difference. Bhagyavardhan, loads of thumbs up. Suraj Pal, yes. Got it. Great. All right. Now, till now we saw about different types of AP. We talked about the first term. We talked about common difference. Now we will see how to find any term of an AP. To know that, we need to find out how to find the general term of an AP. So in AP series, if you wish to find out any term, how would you do that? For that, you would require the first term and you need to add the common difference to it. Like take a look here. Here, these flowers over here, this is representing A. That's my first term. And this is actually representing the common difference. If I add this to the first term, we get our next term, right? So again, I add the common difference, I get the next term. So here what we see is that if we keep on adding this common difference to the previous term, we get the next term. Now you can see that here first term is A, right? Second term is A plus D. I can write it this way. And third term over here is A plus 2D. Now, do you see a pattern over here? See, every time the number which is multiplied with the common difference, it is 1 less than the term number. What is the term number here? That's 2. So, 2 minus 1 is 1. I'm multiplying 1 with D. What is the term number over here? 3. 3 minus 1 is 2. I'm multiplying 2 with it. Similarly, here it is 1. If I subtract 1 from 1, I get 0. So, that's why I haven't multiplied 0 with D over here. Yes. Somebody was asking, number is irrational. Sorry, I could not read the entire comment. Ma'am, please repeat. I did not understand. Anshuman, see how we can find out the general term. To understand that, so how do you get the next term of an AP? To get the next term, we add the common difference to the previous one. Correct? Similarly, the same thing I'm doing here. This is my first term. This is representing the first term, that is A. This is my common difference. To get the next term, to get the second term, I am adding this common difference to it. So see this pattern. This is A plus. How do you do that? So whatever term number is it, you subtract 1 from it and you multiply that with the common difference. Common difference can be irrational. Yes, we did an example. If you see, we did a question where the common difference was root 2. It can be irrational also. That's fine. Yes, Fennel, that's correct. Yes, it can be. Correct. So here this third term number is 3, right? So what I'm doing is to the first term, I'm adding, what I'm doing here is I'm subtracting 1 from 3, we get 2, I'm multiplying 2 with it. So the number which I'm multiplying with the common difference, every time it is 1 lesser than the term number. Anshuman, I hope your doubt is clear now. Quickly, if it is clear to you, you can write in the comment section so that we can move ahead. Yes. Can we use some formula? We will talk about that later on. We have that. We are covering that also in today's session. Ankita Ghosh, yes. Evergreen channel, yes ma'am, clear. Nilajo, Rishabh, Anshuman, yes miss. Alright, great. So how to find out the general term of an AP? Just like I told you, in the first term, what we do is, whatever the term number is, the number that we multiply with the common difference, it is always 1 lesser than the term number. Correct? I'm talking about the general term here. I need to find out nth term of an AP. We are finding out nth term of an AP. So here, what is the term number? That's n. So with the common difference, I'll multiply n minus 1 here, right? Because it is always 1 lesser than the term number. D. Deepa, crystal clear. Suyash, Saif Pasha, Diksha, Padmali. Correct. So general term is, remember this formula, an is equal to a plus n minus 1d. That's the nth term formula for an AP. Using this, you can find out any term of an AP if you have the information given. Yes? So I hope this is clear how to find the general term. Utkarsh says okay. Anshuman, Jan, Miss Crystal clear. Hitesh Kumar okay. Yuvan, Haripriya. Alright, awesome. Now let's try out a question. So I want all of you to try this. It's based on the concept that we just covered. So for the AP 4 by 3, 2, 8 by 3 and 10 by 3, find the 8th term. So first of all, you can see all of them are in fractions. Can I write this 2 over here like this? Can I write this 2 as 6 by 3? Can be done, right? Chalega. 2 can be written as 6 by 3. Now all of them have the same denominator. That's 3. Even if you don't write it this way, that is also okay. Answer will still remain the same. We are just doing it to make it a bit more easier. Yes? Alright. Now, to find the 8th term, we know that we can use the formula of general term of an AP, the nth term that we just saw. For that, I would require the common difference also, right? So, 6 by 3 minus 4 by 3, that's 2 by 3, right? Because if I add 2 by 3 to it, I'll get 6 by 3. Similarly, here also the common difference is same. It's positive 2 by 3. First term over here is 4 by 3. Common difference is 2 by 3. Now, using the formula of nth term of an AP, that is an equal to a plus n minus 1d. We have to find out 8th term. So, 8 represents n over here, right? So here let's substitute all the values. A is 4 by 3, n minus 1 as it is, d is 2 by 3. Let's put 8 over here in place of n. Correct? So we get 4 by 3 plus 7 times 2 by 3. On simplification, you get 4 by 3 plus 14 by 3, which is 18 by 3, and that's going to be equal to 6. Very simple one. Yes, variables are there in place of numbers. Devpriya Charvi, Raj Nandani, Bhagyavardhan. Yes, Sia, Piyush Tiwari, Padmali, Nikesh, Aditi Datta, Devpriya, Virushka. Easy peasy, lemon squeezy. Yes. Alright. So this was a simple one. Now the next question that we have, it's a very interesting question and a bit tricky also. If the mth term of an AP is 1 by n and nth term be 1 by m, then find the value of mnth term. Now please pay attention to this. These kind of questions you do get in exam, especially when it comes to subjective paper, and term 2 is subjective, right? Yeah. Alright. So let's first write down the given information. This says mth term of an AP is 1 by n. What does that mean? Mth term, that's how we write it, is 1 by n. I can expand it this way. A plus m minus 1d is equal to 1 by n, right? That's what we saw in the formula of general term of an AP. an could be written as a plus n minus 1d. Instead of n, I have m over here. So this step is clear. We'll mark this as equation number 1. Yes? D. Deepak, what is mth term? Just like we have 8th term, we have 17th term. Same ways, we have mth term. Instead of a number, instead of a constant, you have variable over here. Yes, such kind of questions you do get in reference books, right? All right. So that's how we can write the mth term. Similarly, nth term is 1 by n. That's how I'll write nth term. Its value is given. That's 1 by m. So we'll expand it. It can be written as a plus n minus 1d equals to 1 by m. I'll mark this as equation number 2. Is that clear? How to expand this? How to open it up, right? D. Deepak, okay, clear. Abhi solve karta hun. Great. Yes. All right. So this is clear to all of you. Fine. Let's move ahead. Now to find the value of mnth term, what do I need? Let's first see what we require for this. Mnth term means instead of a number, we have mn over here. I can open it up this way, a plus mn minus 1d. To find this answer, I would require a, I would require d, but we don't have that. But we can use this information to find this out. So I'll be subtracting equation 1 from equation 2. Yes? Let's subtract this up. So once I subtract it, we get 1 by m minus 1 by m. We will be subtracting these sides as well as these sides. Okay. So when you subtract it, you get m minus nd, right? Mukesh, you didn't understand. Suresh Tagore, you have a doubt as well. Okay. So are these two steps clear? These two equations clear? How we are getting this? First tell me if these two equations are clear or not. Then I'll write everything step by step. Muskan, m over here is denoting any term number. Just say we have 8 term. We just did a question couple of minutes before. 8th term we had to find out. Or let's suppose we have to find out 6th term. So wahan par in place of n you have 6, you have 8. Similarly, here we have m. Right? We have a variable here. So Yash, you want me to explain that one more time? Okay. See how we are getting this actually. Question says that mth term of an AP is 1 by n, right? So here we are talking about the mth term. So first of all, m kya hai yahan par? Instead of a number, aapke paas variable hai. You have a variable over here, right? Mth term, I can write it this way, just like you write nth term, right? This is given. This is 1 by n. And how I can open it? This can be written as a plus m minus 1d equals to 1 by n. Correct? Right? That's equation number 1. Is it clear how we are getting this? Alright. Ma'am, A and D with the first term common difference of the AP. Yes, that's first term and common difference C here, right? Difference between mth and nth term, C. I don't know what the value of m is. It can be 8, it can be 100, it can be 1000, it can be anything, right? It can be any positive number. I don't know what m is. Similarly, nb, I don't know what it is. It can be any different number. But yes, this is for sure. Both these numbers are representing different values, right? M is representing some other value, n is representing some other value. That is why we have got different variables over here. Mukesh Bhagwat, clear, great. Suresh Tagore, thank you very much. You have cleared all my doubts. Amazing. Yes. So it's clear to all of you. Okay. Similarly, I'll write nth term. What is nth term? That's 1 by m. So nth term is 1 by n. We can expand it this way. M plus a plus n minus 1d equals to 1 by m. How to subtract 1 and 2? I'll show you step by step. Don't worry. So this much is clear how we can expand it, right? Now, question says value of mnth term. See, why am I asking you to see this first? So that you should know what do you require to find it out. Mnth term. Koi term number hai ye. I don't know what it is. This is mnth, right? To find this out, what we get? A plus mn minus 1d. Correct? Okay. I would require the first term. I would require the common difference, right? So how do I find it out? We can subtract these two equations. Whether you subtract first from second or second from first, that's okay. Doesn't make any difference, right? From both of them, you will get the answer. So I'm subtracting first from 2. Let me show you step by step. So second equation is a plus n minus 1d, right? From here, I'll subtract the first equation, a plus m minus 1d. First of all, write them in brackets, right? Because here between the brackets, there is a negative sign. So signs will change, right? So here I'll write 1 by m minus 1 by n. Both sides we are subtracting. Right? Is it clear? Yes. Okay, see. Now once you open these brackets up, what do you get? You have a plus nd minus d in the first bracket. In the another one, a plus md minus d. Correct? And you get here, let's take the LCM. LCM is mn. So here we have n minus m by mn. Correct? Okay. Now let's open this bracket up. So we have a plus nd minus d. All the signs will change now. This will be negative a. This will be minus md. This will be positive d equals to n minus m by mn. First of all, tell me, this much part is clear to you? Disha Modi, one more time. So open this up, right? Simply multiply the brackets. You get a plus nd, n is multiplied with d minus d. Here we have a negative sign. This is a plus md minus d. On the right side, I am taking the LCM. Yes, Sukhjot, got it? Yes. Anshuman, is it clear? Simply brackets को multiply करना है, open करना है, change the signs. Mukesh Bhagwat, yes ma'am, clear. Rishabh, clear ma'am. Shrikar SK, not clear. This is first equation I have written here. This is second equation I have written here. Subtract them. Do not put the brackets here. Here also 1 by m minus 1 by n. Then LCM क्या आएगा? Mn. Here will be, we will get n and here we get m. Yes. Okay. Signs are different, so we will cancel them out. This will also we get cancelled. We have what? We have nd minus md equals to n minus m by mn. So from here, what do we get? From here we can see, if you take d common, we have n minus m equal to n minus m by mn. This will get cancelled out. So from here you get the value of d, that's 1 by mn. To simplify this, you have to take the LCM over here. That means LCM would be mn only, right? How do you simplify that when the things are in fraction? Right, Deepak? How would you simplify it? Denominator would be mn and that numerator would be n minus m. Okay. So we have the value of d. That means this is our third equation. Now I need the value of a. We can put this value of d in any of the equations, whether it is first or second. Let's suppose I'm putting in first. So here a as it is plus m minus 1. In place of d I'm writing 1 by mn. Okay, I'm writing here 1 by mn and on the right side we have 1 by n. So on simplifying this, what do you get? You have a plus m times 1 by mn would be what? M by mn minus 1 by mn equals to 1 by n. You see this gets cancelled out. What do we have? We have a plus 1 by n minus 1 by mn equal to 1 by n. This will get cancelled out, right? Signs are same. They're on different sides. Shivranjani, yes. Alright, so value of a would be 1 by mn. We get the value of d and a. Both of them have got the same value, 1 by mn. Yes, Bhagyavardhan. Okay, so now we have the value of first term and common difference. What do we need now? We need the mth term. How to find this out? A plus mn minus 1d. Let's put the value of first term and common difference here. First term is 1 by mn. Mn minus 1 as it is. D is 1 by mn. Correct? Okay. So from here, let's simplify this. Let me show you the step. So 1 by mn plus mn by mn. We are multiplying this 1 by mn with this. And with minus 1 also. Minus 1 by mn. So what is happening here? This gets cancelled. This gets cancelled. We have 1. So final answer is 1. Yes. Correct, Sukhjot. Shivranjani, yes. Mnth term is 1. 1 is the answer, Ankita. Correct. Yes. All right. All right. Correct. So this, yes. Crystal clear. Great. Sukhjot understood. Somujit. 1. Keshvi. Yes, it's 1. Yes. Correct. So I think all of you have understood this, right? All right. So we saw that whenever we have a sequence, right, we have a pattern, we are able to find out any term, right? Why are we able to do it? Because we have arithmetic progression, right? A very interesting concept. But have you ever thought where this actually came from? Who actually invented it? So basically, this was invented by John Carl Friedrich Gauss. He is the father of arithmetic progression. And do you know what? There is a very interesting story behind this. So the anecdote involves his school teacher who wanted to take a break. He wants to take a rest. So he asked the students to find out the sum of the integers from 1 to 100. So that students would remain busy finding this out and teacher would take some rest. So after a few seconds, the teacher saw that Gauss was sitting idle. So he went to him and frantically he asked him that, why are you sitting idle? Why are you not doing addition? So quickly Gauss replied that, sir, the sum is 5050. So the entire class and the teacher was astonished. Everybody was so surprised how he got the answer so quickly. So Gauss was, you won't believe, Gauss was the only one who gave this answer so fast, and the answer was actually correct. And though there were several ways Gauss might have used to calculate this, but this was the only concise, intuitive and elegant visual representation to find this out. Yes, so that's how this arithmetic progression was invented. Isn't this interesting? Yes. See, because of this invention, we are able to find any term of a sequence so easily. 50 pairs. Sorry, I could not read the entire comment. So, Jodh, interesting one. Yes. Fennel, so interesting. Yeah, indeed it is. All right, let's move ahead with our session. So, we will start with the stack of boxes that we used earlier, right? So here you can see that boxes are arranged in such a way that there is one box at the top and there is one more box in the next layer than the previous layer, right? Now let's have some fun with it. So what I'll do here is, we will add the first row with the last one, second row with the second last one, third row with the third last, and fourth row with the fourth last. Yes. Yes, Shrikar SK, nice refreshment. Yeah. All right. So what we see here is that in each row, the number of bricks, if you add up, that comes out to be 9, right? You can see that each one of them has got 9 bricks. And the number of rows here is 4, which is exactly half of the number of layers that we had earlier, right? Remember, we had 8 layers, right? So now the number of rows over here are 4, which is exactly half of it. So this is a trick which will help us in finding the sum of first n natural numbers. Yes. All right. Now let's consider the sum of first n natural numbers. So please pay attention to this, because I'm going to show you how we can derive the formula for first n natural numbers, right? We all know what the formula is, but we should know how it is actually coming, right? Because maths is not about rectification. Palak, your teaching is fabulous, ma'am. Thank you. Okay, so first n natural numbers. So 1, 2, 3 up to n, right? First n natural numbers. The term, see, in each term there is a difference of 1. So the term before this would be what? That would be n minus 1. 1 is subtract karenge, right? To go to the previous term. And the term before this would be n minus 2. If I subtract 1 from here, correct? Derivation will not come in exam, but you should know how the formula is actually coming. Yes, this is only for n natural numbers, this particular formula that I'm showing right now. No, derivation will not be asked in the exam, but yes, you should know the formula, you should know how is it coming actually. Alright, so these are the first n natural numbers. I hope this step is clear to everyone, how n minus 1 is coming here, how n minus 2 is coming here, right? Okay, now we will be using the same trick. Here you can see this is the first term and common difference is also 1 over here. Yes, Fennel, no rectification. Yes. Okay, so to find the sum of the first n natural numbers, let's arrange them according to the trick that we just learned. So what we did in the previous slide, you remember we added the first term, the first brick with the first row with the last one, second one with the second last, third with the third last. Same thing I'm going to do here. I'll add first one with this, second one with second last, third one with third last, so on like this. So what do we get? We get 1 plus n, 2 plus n minus 1, 3 plus n minus 2 and so on like this. Yes? Alright. Okay, so let's simplify this. What do we get? We have n plus 1. Simplify this. This will be n plus 1. Simplify this, you get n plus 1, so on. Every time you will get n plus 1 only. Yes? Yes, this is not like any other subject that you can, do rectification. That's why I'm saying, even if the derivation will not be asked in the exam, but you should know how is it coming actually. All right. So each term is same here, n plus 1. Now you see, initially we started with n terms, right? But then we paired up the terms. We paired the first term with the last one, second with the second last, third with the third last, right? So number of terms, if you think about here, are going to be n by 2 now, right? So n plus 1 times n by 2. This is nothing but this is a first sum of first n natural numbers. This is how this formula is coming. So whenever you have to find out the sum of first n natural numbers, you can use this formula n plus 1 by 2. Yes. All right. So is this clear to all of you, right? How we are getting this? Okay. Let's move ahead. Now we will learn about the sum of first n terms of an AP. So, but what kind of scenario do we use it in, right? So, have you ever thought of this? Well, think of it like an apprentice ceramic started making cups. So, on the very first day, he makes 2 cups, and every day he tries to make 2 more cups. So, on the next day, he makes 4 cups, and the next day, he makes 6 cups on the third day. So, here, this 2 cups is nothing but that's our first term, and this would be our common difference, right? So, if you think about it, as I said, this is our first term, right? On the first day, to get the number of cups on the second day, that means the second term, we simply add the common difference to it. We get a plus d. To get the number of cups on the third day, we can write this as a plus 2d, right? So the total number of cups in all would be equal to sum of all the cups that he has made in all the 3 days. It's very simple to find it out. 2 cups, 4 cups are here, 6 cups, 6 plus 6. You would say, ma'am, that's simple, 12 cups, we will add it up and tell you. But what if the number of days are increased over here, right? What if the number of days are like, it's a bigger number? How will you find it out in that case? In that case, it's not possible for us to add up the, the number of cups on each day and then give the answer, right? So there is a general formula for that now we are going to learn how that is coming. So here, to find out the sum of first n terms of an AP. So here, if you see the previous slide that I showed you, the first day he made a number of cups. Second day, a plus d. Third day, a plus 2d, and so on like this, right? So let's suppose we have n number of days. So a would be repeated n times, right? So I'll multiply this n with a. Deepak, I'll answer this question. Why we cannot use this formula for another questions? I remember in the beginning also somebody asked me this thing. When I was explaining the general term formula, why we cannot use the sum of n terms formula there. I'll answer to that. First of all, please pay attention here how this is coming, right? So a is repeated n number of times. Yes? Okay. Now what I'll do is simply I will be multiplying the common difference over here. We know that it is being added up, right? So the common difference here is being added up 1 time, right? 0 times in the first term, 1 time in the second term, 2 times in the third term, right? And so on like this. If you remember, we learned this thing, right? To get the next term, what we do is the number that we multiply with the common difference, it is 1 lesser than the term number, right? The same thing we are doing here. Okay, so here this is multiplied, and take a look at this. We learned how to find out the sum of first n natural numbers, right? Same way, here it is an AP. Last term is n minus 1, right? So to find out the sum of first n natural numbers, this is the formula that we used. Instead of n, you have n minus 1 and n plus 1. So in this n, if I add plus 1 to it, in the denominator, I'll write 2, multiply this with d. I hope this step is clear. Instead of n, we have n minus 1 here. So this becomes n times a. This is n minus 1 by 2 times d. Yes? Okay. So this becomes what? So after simplifying this, we get n by 2 times 2a plus n minus 1d. This is nothing but this is the formula for first n terms of an AP. Suresh Tagore, clear? Yes? I hope this derivation is clear to all of you. Right? Padmali, favorite lesson? Yes? It's a simple chapter and very interesting also. I'll tell you all the formulas, don't worry. Rishabh, you want me to explain one more time? So here, n number of times a has been used, and whenever we add, here we are adding common difference, 0 times in the first term, 1 time in the second term, third time, 2 times in the third term, like this. Now to find the sum of this, how do we do that? We will be using the sum of first n natural numbers. Instead of n, I have got n minus 1 here. So in place of n, I'll write n minus 1. Here also I'll write n minus 1. plus 1 as it is by 2. So you get this step. On simplifying, you get this step, and on simplification, we get n by 2 times 2a plus n minus 1d. Yes, ma'am, clear, ma'am, and lots of thumbs up. Great. Okay, so sum of n terms is Sn is equal to n by 2, 2a plus n minus 1d. This is what we know, right? Now, I can split it up like this, that it can be written as a plus n minus 1d, right? Okay, and we know that nth term formula is what? That's a plus n minus 1d. So this much part, I can replace this with an, right? And this will become what? N by 2 a plus an. And nth term, right, is nothing but, that's actually the last term. Let's suppose we can replace the nth term with last term, that would be L. So we have another formula, Sn is equal to n by 2 times a plus L. See, I tell you something, these two formulas are basically, these are the two versions of the same formula, right? To find the sum of first n terms of an AP, where first term is a and common difference is t, we have two formulas. If the last term is known, you can use this formula, n by 2 a plus L. If the last term is not known, you can use this formula, n by 2 2a plus n minus 1d. The same way the Gauss was able to find the sum of first 100 natural numbers. Yes? In this one, there is no common difference. There is no d. Yes? See, let's suppose last term is given. Still, if you want to use this formula, you can use if the common difference is given. If the last term is given but common difference is not given, you can use this formula, right? Alright, so these are the two versions of the same formula. Now let's try out a question to get a better understanding. Find out the sum of first 20 terms, right, of the AP whose nth term is given by an equals to 5 plus an. Quickly, all of you, solve along with me. You have the general term given. You need to find out the sum of first 20 terms. You know the formula. For that, you would require the first term, you would require common difference, but we don't have that, right? How would you do that when you come across such questions? Because these kind of questions are asked in the exam. So formula is this that we can use, right? So we have nth term. First of all, you can find out the first term if you put n1 over here. Wherever we have n, we will replace it with 1. We get 5 plus 4 times 1. Yes? Hitesh, thank you, ma'am. Cleared all my doubts. Okay, so from here we get the first term, that's 9. That's the first term now. Now, similarly, to get the common difference, we know that it's basically an minus 1, right? So that could be a2 minus a1. Similarly, you can find out second term. Put 2 over here. You get 5 times 4 times 2. And what will you get? That's 5 plus 8. That's going to be 13. You get the second term. This is what we are explaining here, right? That's how you get the common difference. Put it here. What will you get? You get 13 minus 9. And the common difference over here is going to be 4. So what I'm trying to explain you is, you can find out the first term. You can find out the second term. Subtract them. You get the common difference. So you have the first term. You have the common difference. You have n also 20. You can find out the sum of first 20 terms. Yes? Okay. And we have this formula also to find out the common difference, that nth term minus n minus 1th term. This formula directly can also be used if you want. So you have first term common difference formula, you can use directly. Put everything here. What do you get? You get 20 times 9 plus 20 times 19 by 2 into 4. And that's 180 plus 190 times 4. 180 plus 760. And you get 940. That's the answer. Yes, Keshwi. 940 is the answer. Anju Gupta. Yes. Correct. Bhagyavardhan. Right. Sukhjot. 940, not 94. Yes. 940 aa gaya mera answer. Okay, great. That's the answer, Rajnandani. Perfect. So we know the formula. We have the first term. We have the common difference. See, these kind of questions are important. Again, I'm emphasizing on this because we do come across such questions in the exam. So what you can do is simply put 1 over here in place of n. Then you put 2. You get the first and second term. Find out the common difference. Apply the formula. You'll get the answer. All right. Now, another important thing, that nth term can be shown as a difference of sums, right? So, this formula is not given in the NCERT, but yes, you would find this formula in the reference books definitely. So, the sum of first n and n minus 1 terms of an AP is given. First n term sum would be Sn. First n minus 1 term sum would be Sn minus 1, right? So, nth term can be easily found in that case. You see, first term over here is T1, second term T2, T3, T4, so on. Last term is Tn, and term before that, second last term is Tn minus 1. Correct? Now, I can write it this way, right? I can write it this way, first term, second term, third, fourth till here and last term. Correct? From here, I'll find the sum of first n terms. From here, I'll find the sum of first n minus terms, n minus 1 terms, and this is my nth term. Right? Yes? I hope this is clear. All right. So we know how we are getting this, right? Yes, ma'am. All right, clear. Fine. I can see lots of thumbs up. Yui Gamer, ma'am, you make me understand very clearly. Thank you. Great. All right. So it can be written this way. Sn, right, can be written as the sum of Sn minus 1 plus Tn, right? So sum of n terms can be written as the sum of n minus 1 terms and the nth term. So that's why we are saying that nth term can be shown as the difference of sum of n terms and n minus 1 terms. This is also one formula that you can use directly when you come across such questions, right? All right. So if this and this information, anything amongst these is given, you can use this formula to find out the third thing. Now let's try out a question to understand this. So this is the formula that you can use now. If the Sn, the sum of first n terms of an AP is given by Sn equal to 5n square minus 2n, find the common difference of the AP. Yes. So here we have the sum of n terms in general form, that is 5n square minus 2n, right? So from here you can find out the sum of first term. See, there is sum of first term to nahi ho sakta, right? It would be first term only. I'll simply put 1 over here, right? So wherever we have n, we will replace it with 1. We have 5 times 1 square minus 2 times 1. Correct? Similarly, S2 we'll find out 5 times 2 square minus 2 times 2. Yes, Sanskriti, I am repeating one more time. To find out when nth term, when you have sum of n terms and sum of n minus 1 terms, you can use this formula. Sum of n terms can be written as the sum of n minus 1 terms plus the nth term. This formula can be used. Yes, I hope this is clear, right? Suresh Tagore understood. Sujata Upadhyay, Byju's is best and you're my favorite teacher. Thank you. Sanskriti, okay, thanks ma'am. All right. So you can find out, you can put 1 over here to get, see, this is equivalent to first term. This is equivalent to first term because you cannot have the sum of first term, right? It's just a term number. So from here we have our first term. That's basically what? This is 5 times 1 minus 2. That's actually 5 minus 2, which is 3. And this is going to be 16, right? So from here we can get the A2. A2 would be what? 16 minus 3 because this is my first term. And this is the sum of first two terms. From here you can get the second term. That's 16 minus 3, which is going to be 3, which is going to be 13. And first term over here is 3, right? Correct. We have the second term. We have the first term now. So to find the common difference, that's very simple. It's going to be A2 minus A1. That's 13 minus 3, which is going to be 10. That's how you can find out the. Hitesh Kumar, definitely you can use this formula in the exam. As I told you, it is not in the NCERT, but it is there in all the reference book. And we do find questions like this in the exam also. You can use this formula. Yes. Yes, Mukesh, these are important questions. Yes, these are important from exam point of view. Disha, we have already done a trigonometry session. You can watch it. It's there on the YouTube. Priyanshi Sharma, really adore the way you teach. Thank you. Alright, so I hope that this concept is clear to all of you. So we have covered all the concepts which are there in your book, and I've given you extra formula as well if you come across such questions, right? So that you don't get stuck there. So this was the last question of today's session. So I know there is a lot of stuff, to store in your mind, but don't worry because we have got you covered. And this is not the end. We have lined up many more sessions for you from every Monday to Friday to make you exam ready. Now let me give you a glimpse of the upcoming session. So as I said that we have launched our term 2 crash course today. So our next session is on January 28th, that is Friday. It's on important questions for arithmetic progression, that is 6 p.m. Right? And if you want to have access to more such great content, then please click on the link in the description below and you can get all your doubts clarified instantly during the class. And please like, share and subscribe so that you don't miss on any of the sessions, so that you get notified about the upcoming sessions. All right. No Papiyadas, no Menti today. No Menti. So this was a one short session on arithmetic progressions. All the concepts have been covered in this one session only. Yes. So I hope this session was actually fruitful for you. You actually enjoyed this. So I'll see you soon in the next session. Until then, be curious, keep learning. Take care. Thank you.